Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On this series, Space News from the Electric Universe, we have presented numerous recent findings that challenge the underpinnings of solar physics and the very nature of the Sun and all stars. However, based on a new scientific study, some science media are proclaiming a confirmation of the standard solar model, which states that a thermonuclear reaction powers the Sun at its core. An article on sciencemag.com states, scientists have long believed that the power of the Sun comes largely from the fusion of protons into helium, but now they can finally prove it. An international team of researchers using a detector buried deep below the mountains of central Italy has detected neutrinos, ghostly particles that interact only very reluctantly with matter, streaming from the heart of the Sun. Other solar neutrinos have been detected before, but these particular ones come from the key proton-proton fusion reaction that is the first part of a chain of reactions that provides 99% of the Sun's power. However, as we often see in popular science media, lost is the distinction between fact and theoretical interpretation.
In Science of the 28th of August, there is an article where scientists have long believed that the power of the Sun and most stars comes largely from the fusion of protons into helium, but now they can finally prove it. And it's interesting that they say believed that the power of the Sun and most stars comes from the fusion of protons into helium, because in Nature on the 28th of August, the same day, we have a more definitive statement, and I quote, "In the core of the Sun, energy is released through sequences of nuclear reactions that convert hydrogen into helium," end of quote. But we don't know what goes on in the core of the Sun. We cannot see inside the Sun. It's merely a story. Where we can see beneath the bright photosphere in the center of a large sunspot, it is cooler and dark. This is prima facie evidence that energy is not trying to escape from the interior of the Sun, and that begs many questions. Is the Sun really made mostly from hydrogen, because all other celestial bodies are supposed to have their heavier elements sink to the core? And most of the Sun is supposed to be a radiation zone where the intense X-ray radiation from the supposed fusion in the core is to lose energy over 100,000 years and finally becoming visible sunlight. But there's no known physical body that transfers internal heat in such a manner. But if it's not fusion energy blowing up the Sun to its tremendous size, what is this shining sphere in the sky we call the Sun? The story, of course, is that the core of the Sun is a fiery furnace so hot and dense that protons, that is the nuclei of hydrogen, the Sun's main constituent, it is said, slam together with such force that they fuse. The vast majority of the neutrino flux from the Sun is produced by the original proton-to-proton, or PP, reaction. And I quote, "The PP reaction is the most basic process. Everything that goes on in the Sun stems from it," says Steve Biller of the University of Oxford. It should be noted here that using heat and pressure is the most inappropriate method to achieve chemical reactions, let alone the incredibly more difficult nuclear fusion reactions. In chemistry, we use heavy element catalysts. Why would nature not do the same for nuclear reactions? We do see evidence of heavy elements in the Sun's spectrum. What are they doing there? What's more, the neutrino detectors cannot tell us where on or in the Sun the neutrinos are coming from. The picture of the Sun they give is fuzzy in the extreme. The neutrinos could be generated in the photosphere, which is where we can see all the action. Back to the scientific reports. Researchers have been detecting neutrinos since the 1960s. Initially, a 2/3 deficit in the detection rate confused the results. It turned out that neutrinos could transform from one type to another as they fly through space, but detectors were sensitive to only one of the three types. Here we see another assumption, because there is no detector in space between us and the Sun to confirm this. We need to be aware of the problems that particle physicists are having with their standard particle model. Initially, the neutrino was said to be massless, but no particle can be massless and yet carry off energy from a nuclear reaction. E=mc² tells us that. Particle physics is arguably in as great a mess as astrophysics. At the hearts of both disciplines is unadmitted ignorance of fundamentals like what is gravity, What is mass? What is light? So there is a complex dance in the dark between these two disciplines. Anyway, the reports go on. Once this neutrino problem was resolved, the fact that they detected only about 1/3 of what was expected, neutrino observatories went on to detect neutrinos from almost all the predicted reactions in the Sun, but not the PP reaction, the proton-proton reaction. What makes this PP reaction hard is that the neutrinos have very low energy. That's about the same as the energy of various radioactive decays that happen on Earth, making it easy for an earthbound detector to confuse a decay on Earth with a neutrino event. And I quote, "Detecting neutrinos of this kind is an almost impossible thing to do. You need very low background levels and a lot of patience," says Steve Biller. And here we see a problem with a lot of modern science, that the signals are being extracted almost from noise, and yet they're said to strongly confirm the stories that were already in place. It is a case of confirmatory bias. The experiment that we're talking about here is one by an international team of researchers using a detector buried 1.4 kilometres below the mountains of central Italy. And it has detected the neutrinos, the ghostly particles that interact only very reluctantly with matter, streaming from the heart of the Sun. It's called the Borexino experiment, and it's in Gran Sasso, Italy, below the Italian Apennines. And they've been hunting for these proton-proton or PP neutrinos for 7 years using a spherical tank filled with a liquid scintillator, which produces flashes when struck by ionizing radiation, like that given off by a neutrino. The tank is watched by more than 2,000 detectors that count the flashes and thus the neutrinos. Other solar neutrinos have been detected before, but these particles come from the key proton-proton fusion reaction that is the first part of a chain reaction that, it is said, provides 99% of the Sun's power. The team detected about 90 pp neutrinos hitting Borexino every day. That means the Sun produces enough of them to pump about 66 billion through every square centimetre of Earth per second. That number agrees with predictions of the standard solar model of 60 billion neutrinos per square centimetre per second. Physicists had estimated this number by looking at sunlight, but because photons take perhaps 100,000 years to emerge from the centre of the Sun, it's not a measure of what's happening now. And I quote, "Neutrinos punch straight through the Sun, giving an up-to-date signal that takes 8 minutes to reach us. This again confirms that the standard solar model is on the right track and does an excellent job of describing energy production and transport within the Sun," says Andrew Renshaw of the University of California, Los Angeles. "This is truly a great feat." And of course it comes from that result, that the results show that the Sun is a remarkably steady power source. The reason for this assertion is that if it takes 100,000 years for the reactions that are taking place right now to appear at the surface of the Sun, then getting any kind of confirmation now that the Sun's internal energy is the same as its external output at the photosphere means that the Sun's energy is very steady. Of course, this result could also mean that the neutrinos themselves are being produced in the photosphere, so that the light output from the Sun is no mystery at all. The electric universe does say that the reactions that are detected on Earth are all due to activity in the photosphere. In 1999, I wrote, "Stellar lightning bolts are effective particle accelerators that can synthesize heavy elements in nuclear reactions at the surface of a star. The heavy elements seen in the Sun spectrum are created at the surface of the Sun along with the few neutrinos we observe. That neutrino numbers seem to follow surface and external effects like sunspots and the solar wind is to be expected in an electric star. It is inexplicable in the thermonuclear model." Further to that, in 2001 I wrote, "The electric Sun model expects far more complex heavy element synthesis to take place in the natural particle accelerators in the photospheric lightning discharges. In that case, the various neutrino flavors are all generated on the Sun and do not need to oscillate on their way to the Earth to make up an imagined deficit. What is more, fluctuations in neutrino counts are expected in this model to be correlated with electrical input to the Sun."
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.